talk titled Building Performant Applications with Flutter. So this talk is just basically about building applications and then testing for performance, fixing performance issues or performance related issues, building and fixing such, I say bugs or so, or just working together with your team on fixing these issues. So I have like an itinerary of things that we are supposed to cover. And the first thing we are going to talk about is what is performance. This basically is more of a theoretical topic than a technical topic. Then the second one would be why is performance important? Why is it important to me? Why is it important to other Flutter developers? And why do I need to care about the performance of my application? Then the third topic we'll be talking about is what does performance mean to Flutter developers? This is a different topic altogether from the first one, as we're now bringing it down to us as Flutter developers and Flutter engineers. Why or what does performance mean to me? How do I calculate or how do I quantify performance in my mobile application? Then the fourth one, it would be tips on fixing performance issues. So I'm going to be sharing a couple of tips. Definitely I can't share all of them. There are a lot of different things you can do to improve your performance. And performance is really very specific to the product you're building. So the performance of your mobile application would vary across different projects. So if you're building a project for maybe a health startup or maybe a customer-based product for an e-commerce platform, definitely you would have different performance goals. And these performance goals would definitely influence your decisions on what you consider important in performance or what you do not consider important as it relates to your users. Then the last one should be diagnosing performance problems. I will be sharing a couple of tools and tricks for how you can actually just debug or you can check through to find performance issues with your mobile application beforehand and fix those issues before your application reaches production. So the first question we'll be answering is, what is performance? It's basically just a quantifiable piece of data from a performer. So what you're trying to quantify is this mobile application or is this web application performant? What are the different values I measure from this particular application, and how do I make sure that these values are relevant to whatever I'm doing business-wise? The Flutter team just basically outlined why performance is important. And there are different metrics in measuring performance, but we have to bring it down to at least these 4 different categories because we have like a piece of information we need to calculate and a lot of things that we need to consider. We just bring it down to these 4 main points. So the first point is a performance report should be very easy to consume. So between working with performance in applications, you would have to create what we call like a performance report. A performance report is a report that just shows the performance across different areas of, let's say, your mobile application or your web application or your desktop application. Then we have the second part that is performance has little ambiguity. This basically speaks about performance is basically clear. If you look at a performance report, you should be able to easily tell that this is the performance, this is the data. The data tells me that, oh, I have a few frames that have dropped, or my animation is a bit janky, I need to increase the speed of my mobile app, the size is too big. So you have all this different information at your fingertips. Then the last one is performance is fair. So performance is fair is basically talking about performance is fair across all devices. You can't just tell me that, okay, my mobile app is responsive, but my web app is not responsive. And I'm having issues with my desktop application built with Flutter, it's not responsive, it's having issues, it's not performant. Then you definitely have to look across all your different devices to make sure that your performance is fair across all your devices, it's good, it's okay, and you basically solve all those issues beforehand. So the next topic we'll be talking about is performance in Flutter and how that relates to us as Flutter developers. So I just outlined a couple of things that the Flutter team uses to measure performance, or these are the areas or the key areas of performance we focus in Flutter. If you check on the GitHub repository, any issue related to performance would have any one of these 4 tags. It has different categories, and different teams are definitely assigned to handle different things about these particular problems. So the first one is the speed. The first thing we're going to check is the speed of your mobile application. So I think Flutter has a default speed of, or the default refresh rate of 60 frames per second on 60 frames per second devices, and then you can extend up to 120 hertz refresh rates on 120 hertz refresh rates at enabled devices also. Then the second thing we'll be checking is the memory. How much memory does your application contain? How much memory does it consume? How much, will I say, storage does it consume? But we're not just measuring only the physical space it consumes. We're also going to measure the CPU usage, the memory usage, and stuff like that, and would also get into that. Then we have the app size. This is another important part of performance in mobile applications. Your app size affects mostly your performance and everything that cuts across that space. You always or definitely have to work towards reducing your app size, but it depends really on what you're trying to achieve. So a lot of businesses by default would have a very big app size. Lots of apps will have very big app sizes. And this is not like a cause of concern to them, because they know that irrespective of the app size, they definitely can produce applications that have very high performance. But for a mobile application or a web application or a desktop application that isn't doing too much work, I don't think you have an excuse to have a very big app size, because definitely you just have to bring it down to a level where it's easy for your users to download, it's easy for them to install, and then doesn't really consume much space after it has been installed also. So that is another thing we can look at as performance. Then the last one is energy consumption. This has to do with energy usage of your application and how much energy your application actually uses. So this is a very important metric, and a lot of us do not consider that when we are building mobile applications. So we have to look at how much memory and how much storage, how much energy. And these data points are very, very easy to miss, but we really have to take a lot of them and all of them into consideration when we are building our applications. So the next topic is, what does this mean to Flutter developers? This is bringing performance down to us as Flutter developers, and how Flutter aims to give us high performance by default. So I've outlined a couple of truths here. So the first one is basically, Flutter aims to provide 60 frames per second performance or 120 frames performance on devices capable of 120 hertz update. So I've talked about this basically. It just means that Flutter would adapt to the refresh rate of your device's screen at all points in time. And by default, Flutter is performant. That's the second one there. Flutter is performant by default. It means that if you build a Flutter application, a blank Flutter application, the Flutter team has ensured that on the first run, you're going to have a very performant application on all ends. So this third one is for 50 frames per second, frames need to render approximately every 16 milliseconds. So this is a very important aspect of performance for Flutter. For every frame that renders in Flutter, it takes about 60 milliseconds for it to render. And if it doesn't render around that 60 milliseconds, you would definitely have what we call an animation junk, or a few frames might be dropped. So in the process of trying to build, and while you're running your application, you might have a process or a situation where a lot of animations will get jumbled together because you're trying to run them at the same time. So you have to look into that and find a way to fix that. So I'll be showing later in a later part how we can actually fix animation junks and fix the shader junk issue that came up in Flutter a couple of years ago. So I have a couple of tips on fixing performance issues. These tips just encompass a couple of simple things that we can do to ensure that we do not get caught in a performance trap where we have mobile applications or web applications or desktop applications that are not really performant. So the first one would be talking about stateful widgets. I think we all know what stateful widgets are. How many of us know what stateful widgets are? Okay, so for Flutter developers, we use a lot of stateful widgets. We use a lot of stateless widgets. But one of the most important widgets for us is the stateful widget because it houses our state, and it's basically a building block for other smaller widgets in our mobile applications. So a lot of people do not actually know that stateful widgets affect your performance a lot, because when you're rebuilding your state, you have to have a stateful widget at the top of the tree that ensures that this particular state is being rebuilt each time. And stateful widgets will affect your app in such a way that you have to really control how many times this rebuild occurs, what widgets are affected by this rebuild, and how we can mitigate the number of rebuilds that occur to these widgets in a specific amount of time. So what we'll be talking about is how we can basically work on our stateful widgets or use stateful widgets in such a way that when we build our mobile applications and then we are accessing the state, we are changing the states, and then we're trying to modify the states, we do not have to rebuild these widgets every single time a user clicks a button, a user tries to interact with a search field, or just a random event occurs in the application. So, next slide. So these are a couple of tricks that we can use, or I use, or a lot of Flutter developers use when working with stateful widgets. So the first one is try to use consts as much as possible in your widget. So I've noticed that a lot of Flutter developers do not know the power of using constant and constant widgets in their application. So when you use const before a widget or before a stateless or a stateful widget, you're simply instructing the Flutter tree or the render tree to basically not rebuild that widget a second time after it's been built for the first time. So it's just telling the tree to catch that particular widget, keep it aside, and continue using that same widget for future rebuilds and future changes. Then the second one is, rather than putting state at the top of a page and rebuilding that entire page each time, create a dedicated widget that only updates itself. This is basically telling us that we should try to make widgets that encompass their states in themselves, instead of making stateful widgets that change the state of multiple widgets under. So imagine you have a stateful widget, and then you have another stateful widget as a child of that particular stateful widget. You definitely should not have such occurring. You just have to create it in such a way that whenever you have a stateful widget at the top, it encompasses the state of each of the children in that particular widget. And the third one is minimize the number of nodes created by the build method and any other widgets it creates. So this is basically talking about us not having very long widgets, children, basically. Just reduce the amount of children in every build method. So we can, yeah, it's unlimited, but then having a lot of children in or a lot of widgets in your build method, it actually affects your performance as you go down. One of the ways to easily do this is to break your UI down into different stateful or stateless widgets as you want, and then manage these widgets on their own. And these widgets definitely have to manage their own state on their own without accessing the main state of that particular stateful widget. So the fourth one and the final one is, if a subtree does not change, catch the widget that represents that subtree and reuse it each time it can be used. So this is telling us that if you have a particular widget that does the same thing, basically just reuse, it's safer and it's less expensive to reuse that widget a second time to show that particular piece of data. And also, this is just telling us to make our code more modular in a way where we can reuse widgets and manage the states, reduce the amount of rebuilds that occur, and reduce the amount of states we have to manage. So, next slide. So this is the second part of the tips I'll be sharing. This is another way to optimize widgets. I know a lot of us have seen this argument a lot of times about using methods or using stateful widgets to build the UI. But if you do your research and you dig deeper, you'll actually find out that using methods is basically an anti-pattern for building widgets in Flutter. It's a serious anti-pattern. A lot of experts have argued on this also, so it's a very controversial topic in the Flutter space. A lot of people have advocated for using methods. A lot of people have advocated for using stateless and stateful widgets. But I would definitely advise you to use more of stateful widgets and stateless widgets than splitting your code into methods. So the reason behind this is if you use a method to build your UI, every time the widget is rebuilt, or every time you call setState, it rebuilds the entire widget tree, irrespective of whatever is inside the method. So it does not recognize this particular widget as actual widgets. It just thinks of them as methods it can call to rebuild a particular state. So what it does is that it loops through the children and starts to rebuild each of the children one by one by calling the different methods. So instead of that, we should probably do what's in the next slide. This is a way cleaner and more easier method to use, actually. So in the long run, you find yourself writing cleaner code if you're able to break your widgets into different stateful or stateless widgets. And also, you can also see that there's like a const here. So this means that each of these widgets, 3 of these widgets will only be built once, no matter how many times we rebuild the widget tree. So these widgets are very, very important. It's a very small thing, but it really affects your performance. At compile time, const will make sure that these widgets do not rebuild more than necessary. So the next slide. So another thing we should do while we're building mobile applications and trying to make them performant is to handle our opacity better. So if you're building a mobile application that uses a lot of animations, and these animations have to do with opacity, have to do with tweaking the visibility of objects, making sure that an object shows before another one and disappears immediately after it's done its work. One of the things that's advised by the Flutter theme is to avoid using the opacity widget directly. If you can do that, it's very good. You should definitely avoid using the opacity widget directly. What you should use instead is, I think, an animated opacity widget or a faded transition widget. It's a very simple thing, but most of all these things affect your performance very deeply in very different ways. So when you use, let's go back to the last slide. When you use like a faded transition widget, this allows Flutter to manage the frames itself and make sure that the widget does not rebuild itself each time the animation is occurring, or each time there's a new step in the animation, the widget does not rebuild itself. So you just make sure it's the same widget in the widget tree, but just changes the look and the visual experience as it goes. Same thing for animated opacity. So animated opacity is like a widget that houses a faded transition inside it and manages the state of the widget on its own. So faded transition needs you to have like an animation controller, but if you're using an animated opacity, all you need is the duration and the opacity at that point in time, and it will handle the animation internally. So for the last one, this is a very trivial topic, and it's a very interesting one also. One of the things that's advised by the Flutter team is to use keys as much as possible. So I know it can be a bit bulky, but we definitely need to use keys, especially if you're building or working with integration tests and writing widget tests. You need to be able to find specific widgets, test those widgets, and also make sure that these widgets are working as they seem. Apart from that, the keys help in making sure that Flutter can identify specific widgets and not rebuild them. So if you tag a widget by a specific global key or value key, and then you go to a different widget tree and then you tag another widget by that same value tree, Flutter will definitely know that these are the same widgets and it will not rebuild them. It will use the same state for them when a rebuild occurs. So next slide. So the last one we're talking about is one of the major issues that Flutter had, I think, in 2019 and 2020. There was a major animation junk that occurred when you're building mobile applications on the first run. So on the first run of your mobile app, you would have a lot of junk, a lot of animations will be lagging, and a lot of different performance problems would come up. So I'll be talking about the shaders a bit. So shaders are more like a code that runs a piece of the animation before the animation occurs. So what shaders do is they outline instructions for animations beforehand, and they tell the system what to do, or they tell your mobile app or your web app what to do before the animation occurs, and then they handle it. So if an animation takes longer than 16 milliseconds to run, the mobile application is automatically going to drop that frame. And immediately it drops the frame, you would have an animation that basically just skips from one part, starts the next part, and definitely it won't be a very smooth transition. So one of the issues that we as Flutter developers have when we're building very reactive mobile applications with lots of states, we have to definitely handle this shader compilation junk issue. It's a very serious problem to Flutter developers, and it's really, really, really interesting to work around. So the Flutter team built a workaround for this late 2020, I think, and released it this year. So it's officially out. There's a way to fix this issue, but it's a bit more technical. So next slide, please. So the way to fix this issue basically is for you to cache your animations. So what happens is that you run your application in an integration test. You trigger all the animations that could possibly occur in that mobile application. It saves all that information to a JSON file, an SKLS JSON file. And when you're building your application, you now inject that particular JSON file back into your build process. And it builds with the information from the animation, the previous animation run. And when it has all this information needed, it does not need to try to cache or try to recreate the animations. So it basically knows the animations that would occur in the mobile application. And beforehand, it has gotten all the information it needs to run the application. It has done all the calculations it needs. And it would definitely reduce the amount of frames that run and the amount of frames that get dropped in your application. It would reduce the amount of animation junk and basically bring it down to zero. So this is what we use currently at BottlePay to reduce the amount of animation junk we have. We just cache our shaders beforehand and inject it back in the build process. So I think the first process is basically you run it in profile mode, you cache your shaders, and then you can also purge your existing shaders. Then when you're building your app, you add back the particular JSON file that you ran, or the animation that you compiled, and then you build your application with that information and basically solve the issues for us. So this is basically talking about how we can automate that process. I explained that you automate the process in an integration test. So if you write an integration test for your mobile application, it will be easier for you to basically get all the shaders that are needed and then compile it based on the information that's needed. So if you get an integration test for your mobile app, you run the integration test, it hits all the animations one by one until you're done with every single animation in your mobile app, every single flow for your mobile app. Then you cache all that information to your SKLS JSON file, and you use that information at the end of the process to build your mobile application for production. It reduces all the animation junk and basically eliminates it from your mobile application. So the last topic we'll be talking about is diagnosing problems with performance in Flutter applications. So it's one thing to be able to handle these performance applications before they occur. It's another thing to actually detect them when they have occurred and you need to fix them. So Flutter has a series of tools that we use in fixing, detecting, and also removing animation and performance issues. So the first one is the Flutter performance overlay. So the Flutter performance overlay is available in your profile build. It's a very important tool. what the Flutter performance overlay does is it basically shows you the performance of your mobile application on top, or it overlays it on the app you're running. So every single page you pass through, you would see the information appear in real time on your graph or on the graph, and you'll be able to tell how much GPU your application is using, how much data your application is using, how fast is the animation? Is it 60 frames per second? Is it not? Did I lose an animation frame? Did something drop? These are basically the questions that the Flutter overlay would help you do. And this overlay is not only accessible on the app, it's also accessible on the Flutter developer in the dev tools. So if you check the Flutter dev tools, you'd have access to these same graphs and these same prompts, and you have access to more performance information regarding your applications. So the Flutter Inspector or the Flutter Dev Tools is basically a tool that helps us in interacting with our Flutter applications and finding performance issues, finding bugs in our UI, and basically fixing them. So one thing that this does is you can actually view your widget tree. You can view your networking requests. You can view the amount of data you're caching. You can check your app sizes, check all the information regarding the app size, how much information is being used on the Android part, how much information is being used on the iOS part. You can check the networking for both Android and iOS, for web, for desktop also. So the Flutter Inspector is basically a very important tool for us. It has a series and a load of tools that we can use in checking the performance of our application. But one of the most important ones is inspecting our widgets, trying to make sure that our widgets would definitely build on multiple platforms without render errors. And if we have render errors, we can easily fix them straight from the Flutter Inspector tool without even going to the code to check it out. So I have like a basic recap here of what we've covered. And we've covered what performance, why is performance important, what does performance mean to Flutter developers, and I gave a couple of tips on fixing performance issues, and we just finished diagnosing performance problems. So do I have questions, or does anyone have questions for me?
Hi. For things like if we're loading a lot of images into our app using image.network, is there any performance tip we can use to make our app not junk or something for images?
It downloads the particular image you're trying to view. At that point in time, it caches it, and then when the user reruns the application, it doesn't need to download that image already, because it already has it. So you can actually remove all the assets in your application and then bring them in back as cached network image. You can leave only the essentials, maybe very essential icons, very essential images. But most of all the other assets and images can actually be brought in later in the app as cached images. You can also, one of the important things to also try to do is, if you're using a product that maybe uses a Google Fonts, you can actually use the Google Fonts library instead of embedding the fonts directly. What that does is that the Google Fonts library downloads the font at runtime and caches the font. So you don't need to set the fonts directly. You just use the Google Font library. On the first run of the application, the plugin will download the font, cache the font, and use the font globally across all texts in your application. So is there any other question?
I wanted to ask, like, how is the performance of apps made with Flutter? How is it compared to their native counterparts?
So I think this is an important question because there are lots of different tests and benchmarks that have been run across different platforms. So I can probably possibly share a link to that later. But there's been like an actual research paper on that, that it basically just compares Flutter, React Native, and the native environments. So definitely Flutter is not as perfect as it should be, and also it's not native in the sense of basically using native widgets, and also one last thing to note is that it's definitely more performant than building on some other cross-platform tools, but it's yet, or it might not get up to the point of being completely native. But for now, it's really performant. It hits the required goal for the Google team. So that's okay for us. Yeah. So is there any other questions also?
So for Flutter Web, right? Do you have any tips to reduce the load times?
For Flutter Web, there are a couple of things that you can try to reduce the load time. So currently, Flutter has, I think, 2 different methods of building web applications. So the first one is the normal method that uses that2JS compilation. So there is a second one that uses that to WebAssembly. So that second one is not yet in, I don't think it's very stable because it has a lot of issues, but it's way faster because it's basically converting that directly to WebAssembly code and then building your applications on that particular platform. So I think the Flutter team rewrote the Skia engine for that particular purpose to help it in building the UI way faster than it should or it was previously on the normal that2JS converter.
Sometimes let's assume you have used up, let's say, 80 megabytes of RAM, and then maybe you open another screen. Then the usage reduces, maybe to like 60 out of 80. So my question is there a way to like trim off the extra unused memory, maybe to free it up to other resources or something? Or it just has to stay like that?
Condition, I feel like every page has a performance issue, or you should just think of it like every page has a performance issue. So if you encounter a particular page that has a performance issue, you can easily access the widget 3 and all the information regarding that particular page and try to find out what exactly is causing a lot of memory to be used on that particular page. So performance is not just something that occurs on your first page or the last page of a mobile application. It encompasses through from the first to the last page. So when you say building a performance application with Flutter, it means that from the first page to your last page has to be super performant. It has to be really performant, which means you have to go through all your pages. You have to go to all the screens, all your flows to check if there are any edge cases that you might have missed and try to fix those performance issues before or when your users discover them. So I think I'm actually out of time here. That's the problem. So if you have any questions, you can actually just send it to me on Twitter or something and just DM me and I'll reply that. So thank you very much. Thank you, everyone. Thank you.